We're creating a simple little two-dimensional game called Flappy Bird. We do need to install PyGame. It's not part of the standard library for Python, so you'd bring up a command prompt. You don't have to have an administrator one. Py install PyGame-CE. Pip install PyGame-CE. And I've already installed it. If you haven't installed it, it'll zippy and install it. If you want to update PyGame, do -u. And if there's an update, it'll update PyGame for you. All right. We have the PyGame exit's how you get out. We have the PyGame library. We need to import that library so we can use that code in our game. From the system library built into Python, we're importing an exit command to make sure that we exit the program to the operating system. Width and height are initialized as constants because the game size or the surface size is not going to change, and this is the proportions of the original Flappy Bird game. We do need to initialize the PyGame library, kind of like getting the PyGame engine started. Now we need to create a surface. So what is a surface? This is the display. Over here in memory off to the side is where we draw things. When we're ready to update this whole thing, the whole surface gets updated onto this all at once. So the drawing takes place here. We flip it over to here or update it very quickly. That's called a back buffer over here. It's also called double buffering. You drew your drawing out here in memory and then flip it into the video card when you need to display it. So that's what we're doing, is creating our surface, our back buffer, whatever you want to call it. We're setting it at our height and width. So our display and our surface are going to be the same thing, same size, because they need to match. Here's our display. If our surface is not the same, we end up with missing pieces over here. Not probably the best idea. We're going to set a caption, Flappy Bird, at the top so we know what we're playing. There it is, Flappy Bird. Oh, now we're going to load an image into a variable. Well, first we have to get those images. Whether you're taking my class from Western Nebraska Community College or looking at this on YouTube, there's going to be a link to the tutorial that I'm going through right here. That'll be a PDF that you can read and see what's going on. Oh, it says part 2, so I have the wrong one in there. I have to fix that as I go. This is a link to the assets. And this is a zip file. So we'll need to download that zip file. And I'm going to place it into my downloads folder. Let's get this guy up here. So there's my Flappy Bird assets going into my downloads folder. Well, the next step, now that I'm in the Flappy Bird into my downloads folder, I'm in Windows. So if I right click, I can extract all. And that'll bring out all the images and everything you're going to need. And here's everything that's in there. Background, crashes, music, pipes, different colors of pipes. There's also a PyGame color picker. You can run that and see the different colors in PyGame. So I'm going to run it by using the command prompt. In Windows Explorer, you can create a command prompt at your current folder by clicking up here and typing in CMD. That'll bring up a command prompt at that point in time. There. So I'm in the same folder. I can do a dir to just make sure, oh, there it is, Python, and then the name of the file, PyGame, and I'm going to use tab completion. And there it is. There's all the different colors you can use. When you click on one of these, it gives you the PyGame constant, Dodger Blue 3. The first 3 of these are standard RGB colors, which you can also use. if you decide to change things with your game. All right, so now we need to take all of these, or what you might do is rename this to assets, which is what I have in my program. You would copy this. I pressed F2 to open that up so I could type in it. I'm pressing enter. You would cut this out and paste it into wherever you're doing your program. So for example, if you're doing it over here and you have a Flappy Bird folder, which I'd recommend. So I'm going to create a new Flappy Bird folder. In here, where I'm creating my program, I'm going to paste the assets file. So Control-C copies, or Control-X cuts, Control-V pastes. Then in Visual Studio Code, I'm going to right-click on this. Uh-oh, it went too far down. Right-click on it. Show more options. And if you install Visual Studio Code according to my directions, oh man, there we go. Well, not quite. I have to move up here a little bit. When I right-click, Windows 11 does all these weird things. There it is. You can open the folder with code. With Visual Studio Code, it's better to open folders than to just open a single file, especially when you have multiple files, which we'll have later on. This is my folder that I'm working on, the Flappy Bird tutorial. Up here is my assets folder, and I have other things I've been using as I've been developing things. And this is where I created my flappybird1.py. It's always a good idea when you're developing a program to keep more than one version of it. So when you finish one, go to File and save it as Flappy Bird 2, Flappy Bird 3. That way, if this one breaks, you can always go back to that one, because you never know. Things go wrong. So now we have it in we have the background PNG in our assets folder. Yep, there it is. And we can load it into our background variable. Convert alpha converts the image into a PyGame surface. That helps speed up the game. We need a clock object. So we're initializing a clock object to control the speed of the game. We don't want it going faster for a fast computer and slower for a slower computer. While true means that we have an infinite loop. Well, it's not infinite because we're waiting for all the PyGame program events. We're going to capture them. And if I click the X in the corner, that fires the quit event. We quit PyGame and we exit. So each cycle that we go through, each loop we go through, we get all the events. We go through each event that we've gotten that time around. And for each event, we say, hey, is this a quit? Is this a quit? Is this a quit? So this is for event in events. This gets all the program events that have happened that cycle. And we're going through them one at a time. Remember the surface? We draw everything on the surface first. Filling the display surface with the background image, it clears out the previous frame. If you don't do this, then you can end up with interesting things. So not in this one, but wait till you get to a little further on. Comment this out and just see what happens. As a matter of fact, let me go to another one here, and I'll comment it out in this video just to see. So I have the bird being drawn. I have the surface being drawn. What happens if I don't redraw the surface every time? Let's see. Well, that's what happens. You don't get the surface. It's even worse if you have movement. So let's put that back because I want my game to work. Let's go down to this one where I have things moving around. Let's try it there. Let's get rid of the, where are we updating where are we drawing our bird? Here we are. Let's not draw these. And see what happens. Yeah, not exactly what we want, is it? So each time we cycle through the game loop, we want to replace that background. So try that yourself. It's not what we want. We draw the background. We blit, which is block transfer. The background image or surface is drawn in at 0, 0. 0, 0 is in the upper left-hand side of the screen. We use Cartesian coordinates, meaning x goes 0 through however wide your screen is. Y goes down however wide your screen is. Y goes down in a positive. X goes across in a positive. We want to copy this surface that we've been blitting on and changing things to into video memory, and that updates our screen. So I was talking about surface. This is our back buffer surface over here where we draw things. When we get to the update display, it copies it all over here all at once, but update just updates the changes. So it's supposed to be more computer friendly. And then we cap our game speed. We only go through 60 frames per second. Well, unless you have a really slow computer, then it won't, really slow. You'd have to have a 20-year-old computer not to be able to run this. Well, maybe not quite, but 60 frames a second gives us the illusion that everything is moving smoothly. I think I've covered everything to get you started on your game programming career. Go into step part 2 and start making a Flappy Bird game you can be proud of.